ahead and apply natural log or common log to both sides. I will get the same answer. But why work too hard if I don't have to? So 9 is 3 squared. 3 squared raised to x plus 2. 27 is 3 cubed raised to negative x. I copy the base, multiply the exponents. And now, like here, 2 logs in the same base are equal to each other. Well, the quantities have to equal each other. Same idea. 2 exponential notations are equal and they have the same base. What has to happen? This is so much easier than going through the steps of applying natural log and then being able to simplify it or not, etc., etc. So then what has to happen? If these are the same, if these are equal and they have the same base, what has to happen?
Set them equal to each other.
Of course. So the powers have to be the same. So 2x equals negative 7, so x equals negative 7 halves. No restrictions, no worries. This is an exponential equation. I didn't have to go through this. Not necessary. Exponentials exist for any power, not log. Log do not exist. Logs don't exist on negative or 0, as we looked at the calculator. That's it. What if it's wrong? I don't know. Let's take a look. I check my work, but in this case, please remember, if I want to use the previous answer, although there is no need because I have the answer is negative 3.5, so in this case, negative 3.5, negative 3.5, I have to get the same answer. So I have 9 raised to negative 3.5 and plus 2. And that's the left-hand side. And the right-hand side is 27 to the power of, and the negative will be just 3.5. If both sides are not 0.37, 037, 037, on and on forever, then my negative 3.5 is not good. So I did something. Oh yes, of course, I know what I did. I didn't copy the x right here. Awful. Awful. So, and we have negative 5x. I rushed and I didn't copy the x power. I multiplied here, but I didn't multiply here. Sorry. So 2x plus 4 equals negative 3x. That's correct. So then we have, what should I put here? 5x. 5x equals negative 4. So it's negative 4/5. So x, let me put it on the next page. Yep. It's good that I wanted to show you how to check. I changed the problem by not multiplying, and that's not allowed. Okay. So the answer is negative 4/5. Sorry about that. No intention. So x equals negative 4/5. Good. Back to the drawing board. Good. So first, the negative 4/5. So 4 divided by 5. Good. And 9 to the power of negative 4/5 plus 2. When I hit enter, if I don't get this 13 then I know something is terribly wrong. So the left-hand side, 9 to negative 4/5 plus 2 equals indeed 27 to power 4/5. They are identical. So now I know this is it. Especially on a test situation, I would definitely check. Good problem. Okay, do we need anything else from the equations, or we go backwards to condensing and expanding? Anyone, please? Do we want to see anything else, or we go back to 4.3?
Going back to 4.3 is okay with me.
Absolutely, fine. Okay, so here we have expanding. Here we have true and false. So we have expanding, we have condensing, and we also have the change of base formula. So let's choose from 50 to 59. Anything you'd like to continue with? From 50 to 59. The first set is expanding, the second set is condensing, and then the change of base formula.
We do 50?
Yes. So let's start with 50. In 50 we have log base 6 of 36x to the third. They're asking us to expand into very, very, very simple logs. So this is the product. How do I expand the product? Anyone remembers how to expand the product? We just condensed the log a few minutes ago. We had a sum of 2 logs. So that's exactly what it is. Log base 6 of 36 plus log base 6 of x cubed. But I have to change 36 into 6 squared. And then I bring the power in front. Can anyone tell us how much would be log base 6 of 6? I should write here log base 6 of 6. But what is this?
It would be equal to 1.
Indeed. Log base a of a is always 1. And then bring 3 in front. Log base 6 of x, and this is it. 2 plus 3 log base 6 of x. Good. It was a very good pick. Any questions on this problem? Any questions on this problem? Okay. Anything else? From 51 through 59. Expand.
51 and then 53.
Very good. 51 and 53. In 51 we have log base 4 of the square root of x over 64. And let me also copy 52. Oh no, you said 53, sorry. Natural log of the cube root of x divided by e. Very good. Nice. Good. It's a ratio. So then I have log base 4 of the square root of x minus log base 4 of 64. Yes, I have to change this into 4 cubed. And yes, I have to change this into x to 1/2. We know that the square root is power 1/2. Okay, so it's done. So 1/2 log base 4 of x minus 3, because log base 4 of 4 will be 1. Any questions on this problem? Okay, the other one, first, I have to change the cube root. What power is the cube root? What power is the cube root?
3.
Careful, 1/3. It's always a fraction. So you understand that the cube root of x cannot equal the x cubed, right? So this is power 1/3, this is power 3. Good. So first, I have to bring the power down as 1/3. Then I have natural log of a ratio. Natural log x minus natural log e. Minus because it's a ratio. So how much is natural log e?
Would it be 1?
Indeed, of course, because the base is e. Very good. So this is 1/3 natural log x minus 1/3. 1/3 natural log x times minus 1/3 times 1. And this is it. So this is when it comes to expanding. Now let's look at condensing. (54 through 57). We want to condense.
Can we do number 57?
Yes, 57. Let's start with 57. Good. First, when I condense, no numbers in front of logs. So in 57, we have 1/2 natural log x minus natural log y. Well, we know that power 1/2 represents what? When I bring the power back to x, what does x to 1/2 represent? We just talked about it. If it's power 1/2.
It would be x squared, right?
You mean the square root. So again, the square root of x is not the same thing with x squared. This is x to 1/2 and cannot be equal to this. Good. Minus natural log y. It's a difference, so I know it's the square root of x divided by y. Do not write over y. It's natural log applied to the ratio. Any questions on 57? Okay, let's go on. Change of base formula, unless you want another problem from here. Okay, change of base. 58 or 59?
Can we do both of them?
Oh, sure. So 58 and 59. So we have log base 6 or 72,348 and log base 4 of 0.863. So remember the rule, very simple. This is a ratio. It doesn't matter which log you apply, either base 10, common log, or base e, natural log. Let's say for this one I apply common log. So it's common log of the number 72,348. over the same base, common log, of the previous base. And whatever number I get in a minute. Let's say for this one, I'm going to do natural log of 0.863 and divide by natural log 4. It doesn't matter, the answer has to be the same. If I use log log or natural log, it doesn't matter. So let's find them. So common log of 72,348. Close, divide by. This is not log of a ratio. This is log of a number divided by log of another number. Good. This is it. So I'll copy 4 decimal digits. 6.2448. And the other one, we use natural log on this one. It doesn't matter. As long as you are consistent, top and bottom, they have to be the same. Same log, I mean, over natural log 4. So this is negative 0.1063. How do I check? How do I check that this is the correct answer? Remember, 6 raised to this power has to give us this. What about here? 4 raised to this power has to give us this. Let's check. Good. So I'm going to do the second one because I have the answer here. But the other one, I'm going to round it up because unless I redo the calculation, because I cannot use the previous answer. Okay, now this is the previous answer. So 4 raised to the previous answer, which is this. Should equal 0.863. Now, for the first one, 6 raised to, and this is a rounded number, I will never get 72,348. I will get either a little bit less or a little bit more. So 6.2448, close the parenthesis, and I will never get this number because I did not use the whole thing. But I see the difference is quite big from 43 to 48. But if I redo this calculation, which is very elegant, the calculator can go back now several steps. In a moment, we'll get there. Here it is. So now I press enter and I raise 6 to the previous answer. It is guaranteed to get 72348, absolutely guaranteed. But if I use any approximation, I will not. But now I had the previous answer readily available to me. That's why I said 6 to the previous answer and I got the correct number. Good. Okay. Let's go back to this problem. So we are back to 4.2, in which we discuss logs, and then we're going to be back to 4.1, in which we discuss exponential functions. So let's start with this problem. We had something similar last time. Students in a psychology class took a final exam. As part of an experiment to see how much the course content they remembered over time, they took equivalent forms of the exam in monthly intervals thereafter. The average score F of t. I take notes. F of t, average score. Okay. For the group after t months, I take notes. T is in months. Okay. is given or modeled by this function, f of t equals 76 minus 18 common log log, which is base 10, where t is a number between 0 and 12, 0 months, 12 months. A, what was the average score when the exam was first given? What am I asked to do? What was the score or the average score when the exam was first given? What am I asked to do? Anyone, please? Initially, originally, beginning.
When f equals to t, 0, I mean.
So we plug in 0 for t.